Hello everyone. In this class, I am going to explain you how ESI works. ESI represents electrospray ionization. Electrospray ionization is one of the techniques which is being used as ionization technique in mass spectrometer. In the mass spectrometer, there is initially ionization method, and then there is analysis in the another stage, and finally the detection stage. There are three stages in the mass spectrometer that we discussed in the last class. First one is the ionization. In the ionization, it can be done through two ways. One is the vaporization followed by ionization, or ionization followed by vaporization. But in the case of ESI, it must be initially ionized followed by the vaporization. Let us see how it can be ionized first and followed by the vaporization. See, in ESI, there will be a capillary tube, and the solute, the molecule, will be dissolved in the solvent. And the solvent, once it is filled, the analyte dissolved in a solvent, if it is coming through the capillary, you will be getting a droplet with the same volume. Right? Now, what we do, we need to initially ionize. The solvent present in this solution it is basically proton rich solvents. So due to the acid base reaction in the solution, the ionization may happen. Ionization of the molecule may happen. This is the first way. The second way, if we are applying voltage, high voltage, between the receiver is the analyzer here. There will be a small gap, and through the gap it enters into the analyzer, and there is a capillary tube. If you are applying voltage on the capillary tube and the receiver, in between the capillary tube and the receiver, there will be potential difference developed. Right? Now, because of the electrochemical reaction, redox reaction, the ionization may happen. Right? So, the liquid, there are solvent as well as the analyte. Now, when the voltage is applied, due to the redox, in between, if you see there is a drop here, when the voltage is applied, it will form a cone, and in between the liquid and the metal capillary tube, see, the metal capillary tube will act as electrode. Now, in between there will be a reaction, the redox reaction that may happen. Reduction or oxidation process. Gain of electron is reduction, loss of electron is oxidation. Due to the reduction of the oxidation, it can be ionized. So through this way, this ionization happens. Now, how the evaporation happens? There are three mechanisms proposed. Still the mechanism is unclear. There are a lot of research going on to elucidate the mechanism behind this. But there are three mechanisms proposed till now. One is the ion evaporation mechanism. Second one is charge residue mechanism. Third one is chain ejection mechanism. So, the first one, ion evaporation mechanism, in this initially if you look at the capillary tube very carefully, there will be a Taylor cone produced. Right? It is completely covered with the positive charges. So, there is a solvent, just zoom in. So, there is a solvent, and then inside there is a solute. The solute is the organic molecule. Right? And now, due to the repulsion, see, there are positive charges. Right? So, what happens? It will get accumulated due to the cone formation. It gets accumulated at specific region. So, there will be accumulation. So, more accumulation happens at the corners, and inside the analyte will be. Now, due to the repulsive force, it gets splitted into two drops, and then positive. So, the analyte will be coming out. This is called ion evaporation method. Only the ions will be evaporated out. Right? There is a solvent. The solvent will be containing the charges, and now due to the voltage difference, there will be cone formation. At the cone there will be more charge accumulation due to the repulsive force will be acting against, so that it gets splitted into multiple droplets, but finally you will be getting the ions out, right? Only ions will be evaporated out from the droplet. This is called ion evaporation model. In the case of charge residue model, there will be analyte and there is a solvent. Now when the voltage is applied, only the solvent will be evaporized, right? So due to the evaporation of the solvent, finally we will be getting only the residue, only the solute as a residue. That residue will be entering into the analyzer. In the case of chain ejection model, so there will be positive charges and there will be chain structure inside that has the positive charge in it, and that chain will be coming out at last due to the repulsive force, right? So what is evaporation? Evaporation is nothing but becoming vapor, becoming gas. So when it is becoming gas, there is a surface tension, right? So it should overcome the surface tension, then only it will become vapor. It means the interaction between the solvent, within the solvent should be broken. The interaction between solvent and the solute should be broken. In the first case, the interaction between the solvent and the solute is broken. In the second case, interaction within the solvent is broken. So the solvent gets vaporized, the solute, the analyte is coming out. But in the first case, the solvent, between the solvent and the solute is broken, so that the solute comes out, right? This is how it works. Chain ejection, through the repulsive force it comes out. Okay, so overall, see, the solution will be containing the analyte ion. During the spraying from the capillary, the more charged compounds will be accumulated. So due to the accumulation, there will be repulsive force. So due to the repulsive force, the droplets will be becoming tiny drops, microjets. Those microjets will be having the analyte. So each microjet will be having analyte along with the solvent surrounded, and the analyte, finally it will become only the analyte. When it enters into the analyzer, finally it will be only analyte, the solvent will not be getting into, right? If it is non-volatile solvent, the solvent may also enter into the analyzer, but normally we use only volatile solvents, right? So solvents will be vaporized during the ionization process itself. So only the analyte, only the molecule enters into the system. This is how ESI works. In the next session, let us see how the matrix assisted desorption ionization works. Matrix assisted laser desorption ionization method works. Thank you.